Hello and welcome. Today we are going to look at differentiation from first principle. Okay, differentiation from first principle. But before we look at that one, let's look at the main definition of differentiation. When we say differentiation, what does it mean? The method of finding the slope of a tangent to a curve at any point on the curve is called differentiation. So when we say differentiation, in other words, it's a method of finding a slope. And when we say a slope, I hope you know what a slope is. We are talking about what? A gradient. So anytime you find a differentiation, the answer you get is the same as what? A gradient or a slope of a point on a tangent. Is that okay? Very good. Now let's look at formula for finding the differentiation from the first principle. So this is the formula for finding the differentiation from the first principle. Dy dx equals f prime of x equals the limit as h approaches 0 of f at x plus h minus f at x all over h. Now we denote the differentiation by dy dx or f prime of x. This is the first principle or the first differentiation. So in this case, the dy dx can also be written as f prime as x. So whether you use this one or use this one and you equate it to this. Is that okay? Very good. So now let's see how we can solve this. So this is the formula. Anytime the question asks you to find the differentiation from the first principle, you are going to use this formula. And either you use dy dx equals to this or f prime at x equals this. Okay. Okay, now let's look at these examples. Differentiate from the first principle with respect to x. Y equals x squared, y equals x cubed, y equals root x, then y equals 1 over x, the y didn't come, x plus 2 to the power 2, all of them to the power 2, so y equals to that, y equals s cubed plus x. So let's start with the I. Y equals x squared. Now, you know that this y can also be written as f at x. This is a function, okay? So in this case, we can say that f at x equals to x squared. Is that okay? Now we are using the first principle, so use the formula. So the formula, which one are you using? If I'm using dy, I can use this denotation. Dy dx equals the limits as h approaches 0 of f at x plus h minus f at x all divided by what? H. Is that okay? Now, how do we get this so that we can substitute? For the f at x is already given. And f at x is given as x squared. Now f at x plus h. For the f at x plus h, what you are going to get is that when it was f at x, we have x squared. So f at x plus h means that we are going to replace wherever I see x, I'm going to replace by x plus h. So here is going to be x plus h all squared. So we can expand this to get x squared plus 2x plus 2xh plus h squared. Is that okay? So here, when I come to the formula, dy dx is equals to the limits as h approaches 0 of x plus h minus f at x all divided by h. So dy dx is equals to the limit as h approaches 0. Now f at x plus h is the whole of this. So I'm going to have x squared plus 2xh plus h squared. F at x is just x squared, so minus x squared all divided by what? H. Okay. So my dy dx will be equals to this, and that will cancel because they are of opposite sign. Can you see that? So what do I have left here? I'll be having 2xh plus h squared, all divided by h. Now in this case, there's h here, there's h. I can factorize it out. So what am I going to have? Dy dx equals to the limit as h approaches 0. H, I will have 2x plus h, all divided by h. So this h will go with this, so that I have dy dx equals the limit as h approaches 0, 2x plus h. Is that okay? So here, the final answer to this, we are now going to substitute the h approaching 0 here. So wherever I see h, I put 0 there. Now because this one is h, you consider all this one as constant. So the whole of the 2x will be considered as constant. So our final answer will be 2x. But let me clean here. Make sure that you screenshot their questions so that you can solve them. So this one, I'm now going to have dy dx equals, now when you start the substitution, don't bring the limit again. So I have 2x plus 0. Wherever I see h, I put 0 because they say h is approaching 0. So we treat the whole of this as constant. So dy dx equals what? 2x. So the answer to that question is 2x. Is that okay? Now let's look at the second example. Okay, so this is example 2. We have to use the first principle to do this. Y equals x cube. So per this, you know that our f at x is equals to x cube. Then f at x plus h will be equals to x plus h cube. Is that okay? So let's expand this one. If I'm to expand this, I'm going to have x plus h squared times x plus h. Is that okay? Now you see this one and that will give you this. Now you know how to expand this. For the expansion of this, we have x squared plus 2xh plus h squared. The way I'm expanding this, if you are confused, just do this. X plus h, x plus h. Then you do it one by one, you get this. Okay. Now from here, remember the whole of this is multiplying this one, x plus h. So by opening it, I'm going to have x squared times x, which will be x cubed. S squared times h, that will be s squared h. Then 2xh times x will be 2x squared h. 2xh times h will be 2xh squared. Then the last one, h squared times x will be xh squared plus h cubed. So now f at x plus h is the whole of this. So we are now going to put the whole of this into the formula. So you know that our formula is dy dx equals f at x plus h minus f at x all divided by what? H. So with this, I can have dy dx to be equals to f at x plus h is the whole of this. So that is s cubed plus x squared h plus, so let's see something. This is s squared h. This one too is s squared h. So I can add them. That will give us 3s squared h. So we have 3s squared h. This and that, okay? This is 2x h squared, and this is x h squared. They are the same. So I can also add that one to get 3xh squared. Then h cubed. You are saying that the whole of this is divided by what? H. So here, my dy dx, okay, I'm not done, minus f at x, was given as s cube. You shouldn't forget that, okay? All right. So dy dx equals, now this and that will cancel out, leaving 3x squared h plus 3xh squared plus h cube, all divided by h. Is that okay? So you realize that you have h here, h here, h here, so I can factorize it out. So dy dx will be equals to h out 3x squared plus 3xh. This h is 2, so 1 coming out, leave it 1. And this is h squared, all divided by h. We have h cubed, so if you bring 1 out, you leave it h squared. So this h will cancel the h here. So that at the end, so you see I'm making a mistake. Because when you are doing it without bringing the limit, it is wrong. So here, I'm supposed to bring the limit as h approaches 0. The limit as h approaches 0. The limit as h approaches what? 0. Don't bring the limit, it is wrong. So dy dx is equal to the limit as h approaches 0. What am I going to have? 3x squared plus 3xh plus h squared. So you see the aim here is that we are doing so that we can cancel the h out. If you look at the first one, we did the same thing that we applied there. So here, now that I'm done with this, I can now substitute the 0 there. So wherever I see h, I put 0. So that one, when you start the substitution, you don't bring the limit again. So dy dx will be equals to 3x squared plus. Now if I put 0 here, that will be 3x times 0, which will be 0. If I put 0 here, here it will be 0. Means that my dy dx will be equals to 3x squared. Is that okay? So this is how we solve first principle. Let's look at another example. Okay, so this is the next example. Y equals root x. We are using the first principle to do it. So we have, first, let's identify f at x. F at x will be root x, okay? F at x always equals the y equals root x. Then you look for f at x plus h. So wherever we see x, we put x plus h there. So now we come to the formula. Dy dx is equals to f, is equals to the limits as h approaches 0 of f at x plus h minus f at x all divided by h. Is that okay? So here the aim is to be able to remove this h. But if I put 0 here, to be undefined. Okay. So looking at this one, dy dx will be equal to the limits. I'm saying that if you don't bring the limit, you are wrong. F at x plus h is root of x plus h. X plus h minus f at x is root x all divided by h. Okay. So here, I've already done said with you. When you have something like this, you have to conjugate. In this case, the conjugation will be at the top, the numerator, okay? So here we have my dy dx equals square root of x plus h minus square root of x all divided by h times, so I'm conjugating it. That gives us root x plus h plus root x all divided by root x plus h plus root x. This is how it's going to be. So I have dy dx equals, now the whole of this is multiplying this and this is multiplying that. And when we are doing the set, I told you that where we conjugate, that one you expand. And where we do not conjugate, you maintain it. So let's expand this by that. Remember, the whole of this is multiplying the whole of this. So this one will multiply this and that. This one will multiply this and that. So we are going to have root x plus h times root x plus h. The one under the root are the same. So it will give you x plus h. So here will be x plus h. Root x plus h. Now here, I will not even waste my time to multiply everything, because you know already that if I multiply this one by this is what I will get. If I multiply this one by this, and I also multiply this one by this, they will be the same. So I'll cancel it out. That's the difference of 2 square. So what you do is that when you get the difference of 2 square like this and that is the same, this and that is the same, the sign here is minus, here is plus. When you have something like that, you just take the first one, multiply by the first one here. Take the last one, multiply by the last one there. So negative root x times positive root x will be negative x. All divided by h bracket open root x plus h plus root x. So I'm going to have dy dx equals, so this will go with this one. So that I have h over h bracket open root x plus h plus root what x. So you see this will cancel with this or go with that. H going to is of 1. So I have dy dx equals 1. Okay, I'm always leaving the limit out. So here supposed to be the limit as h approaches 0. The limit as h approaches 0. The limit as h approaches 0. So I'm going to have the limit as h approaches 0, 1 over square root of x plus h plus root x. So now here, if I put h to be 0 here, still I won't get 0 at the denominator. What we are doing is that we don't want to get 0 at the denominator. That's why we do some simplification. So now here I'll have the limit. I'm going to now do the substitution, dy dx. Now I've told you that if you are doing the substitution, you don't bring the 0 again, the limit again. So here will be 1 over square root of x plus 0 plus root x. So dy dx will be equals to 1 over square root of x plus 0 will be root x plus root x. You see they are the same, so you can add them. That will give you 2 root what x. So this becomes the answer to that question. Let's look at the last example, then I'll give you one to try, or you try the ones that was left there. Okay, good. Okay, now let's look at how we can use the first principle to do this. Y equals 1 over x. So here, our f at x will be equals to 1 over x. Then our f at x plus h will be equals to 1 over x plus h. So if I code the formula dy dx from the first principle, I'll have f at x plus the limits as h approaches 0, f at x plus h, all divided by minus f at x, all divided by what h. So let's see, dy dx equals to the limits as h approaches 0. Now f at x plus h is 1 over x plus h. So here will be 1 over x plus h minus f at x is 1 over x. So here will be 1 over x. Remember this one is divided by what? H. Now here we find the LCM of x plus h and x. And what will be the LCM? The LCM will be what? X plus h multiplying by what? X. So you are going to have, let me do that one separately after I'll come and put it there. It's like we have 1 over x plus h minus 1 over x. The LCM will be x plus h. So x plus h going to its of 1. Leaving x here, x times 1 is x. Minus x going to its of 1. Leaving x plus h. Okay, x plus h times 1 will be x plus h. So in this case, if I expand this, I'm going to have x minus x plus h. all divided by x times x, which is x squared plus xh. Is that okay? So this one will cancel with this one, leaving h over x squared plus xh. So with this one, what I'm going to do is that now the whole of this way, I'm going to replace the whole of this way by h over x squared plus xh. So that's what I'm going to do. That's what I've just simplified and I've gotten this one. So I'm going to have dy dx equals to the limits as h approaches 0, h over x squared plus xh. Remember, the whole of this is dividing by h. But do you know that I can bring the h to this one, because it's like this. If I have h over x squared plus xh dividing by h, you know this one is over 1. So when I'm doing that, I'm going to have h over x squared plus xh times 1 over h. So 1 times this will be h. This time that is going to be h bracket open x squared plus xh, something like this. So what I'm going to do here is that this one, the whole of this one is now this h over h bracket open x squared plus xh. So that's what I'm going to have. So you could see that this h go into h 1 time. So you have dy dx to be equals to the limits as h approaches 0, 1 over x squared plus xh. Now at this point we can do the substitution. So our final answer here now becomes 1 over x squared plus 0 x times 0. Okay, so therefore dy dx will be equals to 1 over x squared, because this will give you 0. So that's the answer to this question. Is that okay? Thank you very much. Solve the rest of them and leave your answer in the comment section. Thank you.